In this section, we're going to discuss the interfaces list and collection. Generic programming is the concept of writing one piece of code that can be used with different data types. Technically, the compiler will have to write different pieces of code based on each data type, but generic programming allows us programmers to write at one time, and the compiler will simply modify that code per type. This saves us a lot of time and provides a generic framework for solving algorithms using various data types. Collections allow parameterized types, just like I explained with generics. That is, we define a collection as a container that will hold objects, but we don't specify the exact object type. We just use a variable that stands for the type. The compiler will figure it out. Typically, we use the letter capital E, which stands for element type, and we just say given E, and the compiler reads that as given E of any type, do this or do that. And when we actually create the collection, we will specify the type. The compiler will add in that type information, and the code works. A programmer cannot use a collection directly. It's an interface, therefore it describes what methods must occur, but not how to do them. The class implementing the collection will determine how to actually do those behaviors. A list extends the collection. It adds more to it. One notable difference between a collection and a list is that the list has the idea of order. If we were to add 3 elements to a list, A, B, and C, in that order, the list will maintain that order. A collection doesn't have to. A list does. So a list is a collection, but more. A concrete class is one where all abstract methods, either from an interface or an abstract base class, are defined. That is, there are no undefined methods. We can instantiate an object of that class. The ArrayList is a concrete class which implements the list interface, which itself is extending the collection interface. Therefore, the ArrayList will have all the abstract methods defined. So in concept, an ArrayList does everything a list does and does everything a collection does. Because it's a list, it maintains order. It has the ability to index. A notable property of concrete classes that implement a particular interface like list is that we can swap which concrete class we're going to use. An ArrayList is good for many things, but it has characteristics that may not make it favorable for everything. In that case, it would be nice to have a linked list, for example, that has different properties of runtime behaviors that is more ideal for a particular application. Which one we choose is important based on its performance characteristics, but not important for how it works. They both work the same. If we deal with either one as a list, it'll work identically. We don't care which one we use as a concrete class. Here's an example. Let's assume we have a list of double values, capital D double values, and to make the example real, let's say that this list is very dynamic. We add and remove elements continually. We start with an array list, and then we discovered over time that the array list is not all that performant because of its internal characteristics. It doesn't allow easy removal of elements and then addition of many others without performance impact. We determine this and say, I think a linked list would work better performance-wise. We swap it out in the creation of the list, and lo and behold, our program works much better. Performance is increased because the characteristics of a linked list are better for insertion and removals than array lists are. No client code or no other code changes, only where we create the list. So new array list or new linked list. That's where it changes. This is the power of using interfaces and generic programming.